So the very first I'm doing the pip installs to get all the necessary libraries, and then I'm taking the HF token, just authenticating to get the model. And then we have the inputs. So the first one is import torch. So why am I using that? Like PyTorch provides tensor operations and GPU acceleration for model inference, as we all know. So we will use it to manage our model and move the data between CPU and GPU. So this kind of stuff we need torch, and this is from the PyTorch, like a deep learning framework. And then we have the from transformers input this auto processor, auto model for vision to sequence. So this imports two classes from the Hugging Face transformers library. The one is, as we know, auto processor. So this handles processing of inputs, that is text and images. And then we have auto model for vision to sequence. So this is a vision to sequence model for tasks like OCR. So this is very much essential for loading and using our pre-trained SmolDocling model. Okay, that model, like, which is converting images to text. And then we have a pill. So this imports the image from the pillow library. So this is Python imaging library. And as we all know, pillow handles image inputs like loading and passing them to the model for processing, right? And then we have a docling code. So this docling code types importing of docling document and doc tags. So the first thing is this docling document represents a structured document. Like we are just importing this class, which will help convert our raw model outputs into structured formats. And even doc tag also does the same thing. So it just handles the doc tags, like structured outputs from the model. And then we have a Gradio. So everything we are trying to put it in the Gradio UI. So this is like just for web-based interfaces. And then I do have a time, like, to just measure how long processing time takes and all. And then we have pandas. We all know, like, we use this for data manipulation. And like, why is it really necessary is, like, we will use pandas to create some data frames to display the batch processing results in some data frame or tabular kind of format. So that's the reason we are using it here. And then we have the model initialization part. So this one, device equal to CUDA, if torch.CUDA is available, that function, else, like, we have to use CPU. So what it does is, it sets the device variable to CUDA if GPU is available. Like it is checking it via this particular thing. Otherwise it will ask to take CPU. So most of the time deep learning models run much faster on GPUs rather than CPU. Why? Because GPU have the parallelization. So that's the reason. And then we have the processor. So here this loads a pre-trained processor for the SmolDocling model from Hugging Face model hub. So we are just taking that. And then we have the model, which is equal, like, here we are loading everything, like pre-trained everything into the model. So what exactly we are doing here is, this loads the pre-trained SmolDocling model and moves it to some specified device. Like here, device in the sense, it is CPU or GPU that we are using from this line. And the model performs the core vision to sequence task, whatever the conversion of image of text into text sequences. For that reason, we are moving it to the device, like CPU or GPU, so that it ensures like, we are running it on a good hardware and we get the quick processing done. And once we have this, we have the processing function. So what this do is, this function processes one image at a time and performs the specified OCR task. Okay. We can go step by step here. So start time, like, I'm just recording the current time using time.time. And then I do have a messages. Like, this is a dictionary. Like, it creates a list of dictionaries representing a chat like message structure. Like why we exactly need this is, the SmolDocling model expects input in a conversational format, like, where it has to combine the image and the task instruction. So that's the reason we need this. And then we have a prompt, which is like processor.apply chat template. So what is this? So this is where, like, we are trying to convert the messages into some formatted string using the same method. And then we have inputs, like, where we are calling the processor and we are giving text, images, and we are asking it to return PT. So what does this return mean here? Like, return tensors is, it will return PyTorch tensors, and images where we send image, and prompt is where, like, the formatted text prompt is going, and everything we are getting it to the device, like either GPU or CPU. And the like, why we need models, like, why model takes input as tensors is, they must be on like, generally they must be on some device for the computation. So that's the reason we require tensors. like that's in the sense like we as a model requires tensors. And then we do have a 27th line, which is generated IDs. So what exactly we are doing here? So this runs the model, like whatever the model dot generate. So this method is used to produce output token IDs. So the whatever the core inference step, like where the model process the image and prompt to generate a sequence of tokens. So that is being done here, and we have put like max tokens to 1024 tokens. And then we have the next thing, which is whatever the we have the prompt length. Excuse me, let me just go back here. I think this 28th line. So here what we are doing, like this 28 and 29, so this two lines will calculate the length of the input prompt, which is coming from the prompt length, and it trims it from the generated output. Okay, so why exactly we have to do that is, once we have the output generated, which includes some input prompt tokens, right? So we only want the new tokens which are generated by the model. We don't want what was the input, right? So that's the reason we have to chunk or slice them up. So that is what we are doing it here. And then we do have a doc tags, which is like batch encode, and we are replacing doc tags. So what exactly we are doing in these two steps is, this decodes the trimmed token IDs into text and cleans up the output. So if you can see here, we do have batch decode, like which converts token IDs to text, and then and then we are giving the trimmed generated IDs, and special tokens we are just skipping it. And then we have 0, like this means like it takes first item. Okay, and then we have the else step, like as we all know, it just removes leading white space. And then we are doing the replace thing, like removing some any special tokens which are available, and then stripping it. So that's all. And then we have these two lines. Like in these two lines, what we are doing is, if the task is about converting a formula to LaTeX, okay, then that particular thing will be done by these two things. And then if okay, so once we have, okay, forgot to mention that. Yeah, so here in this particular step, LaTeX syntax should be always wrapped in dollars. So this is just used to render some mathematical formulas, so that it comes in a proper markdown format. So that's the reason you're seeing like two dollar symbols in the front and back. And then we have the else part. So in this else part, what we are trying to do is, we are doing some other tasks, like creating a doc tag document from doc tags and images. And then we are creating docling document, and then we are loading it into, like load all the doc tags into some document, and then we are exporting as a markdown. So this is only used for non-LaTeX tasks, like example tables or text extraction. So where we only use docling code to create the structured markdown output. So that's the reason we use this code here. And then we have the processing time. So obviously we need to know what is the processing time taken, and it's returning 3 values here. So the first one is, it's returning doc tags, which is raw text output, and the second one as a MD content, which is markdown formatted output. And then we have a formatted processing time string. So how many seconds does that code took to run. And once this is done, like we have another function, which is where we are trying to process multiple images sequentially. So it's almost similar, but here we are just defining the function that takes a list of images, and whatever the task type is, and it initializes from its empty list, and then it handles the batch processing. So this is like very traditional way of doing anything, right? So I have done the same thing here. And once this is there, like we have the Gradio interface function. So this is very, very basic. So we are defining a function that takes some UI inputs, like upload type, single image, multiple images, and what is the task and all. So this everything, like if upload type is equal to single image, then call the process image. If it is multiple image, like process multiple image functions. This is like very, very basic. And once we have all these things, we have task options. So in task options, we have a list of options where we are asking user like to select. He or she can choose from this list, and get the output accordingly. And once we have this, like we are just enhancing the Gradio interface with some icons, and also it's just beautification code, I can say. So it's all about that. So once it is done, like we have a launch. Once we run this particular cell, so we'll be ending up with this kind of text. So once you go to this part, so now let's look into the app. So here I have a UI like which supports single image and multiple images. So for time being I will go with single image. So here we have to just click on upload, and once we have it, like I am choosing code. Like this is a page where we have code as well as text. So I want to extract only the code from it, like in some tags. So convert like code to text. So I'm just selecting like process images. So once I do that, the extraction results is going to be present here, and we can see even what is a processing time taken and all. So it's just doc tags here. So yeah, the results are here. So let's take a close look at what this page consists of. So this page consists of text as well as code, and here we can see that the code is in 3-4 blocks. So this got extracted here, as we can see 1, 2, 3 and 4, and this is really well, and as we can see that it has given me in the tag of code. And let's upload any other image now. So I have to upload. So I'll take one page which is just a kind of a academic page. So let's see, and here I just want this page converted to the document. So let me just process this. Let's look at the results. As we can see, this image is a research paper, so which talks about OCR for document and newspaper. So I'm expecting this everything needs to be converted to docling type. So yeah, so we can see here doc tags which are good. So everything here is present within the doc tags and neatly there. I think everything got extracted, and we can see even whatever it is written with the citations as well. So it also captured all those things. I think the challenges faced are detection of text in our natural scenes as well. I think that part was just left out, I guess. So this part didn't convert. So but this is fine, this is like really good. We need to make some changes to the code, I guess, to get it properly captured. And yeah, in the markdown also we can see the text is beautifully presented here. So we can just do the copy and paste if you want to just paste it somewhere. And yeah, there are no batch results because I'm not sending anything with the multiple images, so let's not worry about it. And now let's do the other thing. So I do have a table here. So let's see how this gets converted. So convert this chat to OTSL. So just clicked on process images. So as we can see, the results are out, and this is really cool. So okay, we are done with the chat, code, table is also done, page is also done. So the last thing which is convert formula to LaTeX. So we'll just upload one more image, so which is this one. Okay, we'll just see how this works. So let it process. So as you can see, the formula is extracted. Let's look into markdown. Yeah, this is perfect, like 11 plus x divided by x cube, and then 2x 5 minus x. Yeah, this is perfect. So this is also we can use directly the LaTeX formula, and this is really helpful for research. Like whoever wants to write research papers, academic papers, this is really good. And then we have something like table to OTSL. So let's even do that. So we have this. So let's just process this. So yeah, as we can see that the table is converted to TSL format, and now we can just check the markdown. It's good. It's not that perfect, but the perfectness with the age, because we see the age for every column, but here it's like it didn't cover the last one. But I think all other things were really good, and this preferred CDA, like even this got a bit messed up, I guess. But other than that, like I think most of the times it's good. The values are really perfect. We have to just do some data manipulation thing here. Once we get it in the pandas symbol, then we are good to use this. Right, folks, that's a wrap on building this SmolDocling OCR application. So we have walked through how to extract text, tables, and formulas from images using these small docling model, and we have even built a good Gradio UI. So you have got all these tools now to turn images into structured data just with few clicks. I have also included a detailed README in the GitHub repo. I'll leave that link below. And so please check it out if you found this helpful. Don't forget to like, subscribe, and drop a comment with your thoughts or any code tweaks that you have made to this code. I would really love to hear about that. And thanks for watching, and I'll see you in the next video.